Hello, my name is Amit Kumar and I'm currently completing a clinical exercise physiology degree at the University of New England. I am completing this presentation as part of my assignment Exercise 335, Motor Control and Human Development, which is coordinated by Dr. Dominic McNeil. The topic for my presentation is based upon a laboratory activity relating to fatigue and performance. Fatigue has played a significant role in one's motor control movements. Researchers have been interested in the relationship between fatigue and motor performance for quite some time. There are two types of fatigue. These are known as central fatigue and peripheral fatigue. As mentioned before, central fatigue relates to the central nervous system. Central fatigue can be initiated when the brain becomes overheated or overstressed. Biochemical changes occur when the body temperature increases during prolonged intensive exercise. When central fatigue initiates, the brain is unable to send enough information to the muscles to maintain sufficient muscle activation. This then generally results in fatigue, sleepiness, loss of drive, and reduced muscle force. The other known fatigue is known as peripheral fatigue. Peripheral fatigue takes place when the motor units within the muscle change during exercise as a result of sustaining fatigue. Peripheral fatigue is caused by a lack of energy substances within the muscle, which results in the buildup of lactic acid. Peripheral fatigue is most common when individuals perform endurance and strength exercises. However, peripheral fatigue slowly adapts to forces applied to the muscle, which increases energy supply and waste removal. Schillings et al. Mentions that most research focuses on how fatigue impacts performance while conducting maximum contraction rather than how does fatigue impact learning. This indicates more research needs to be applied to learning abilities whilst fatigued. This leads us to our practical run by fellow classmates to analyse how fatigue impairs performance. Participants were asked to be in pairs and to complete a throwing task both under fatigue and in controlled conditions. Participants were required to perform the task one after the other, so one partner would be doing the fatigued activity first and then the control trials, and vice versa. The task required both participants to perform 10 trials, beginning with and interspersed with 3 minutes of either physical fatiguing exercise or rest. Participants were required to perform 3-minute step-ups on blocks, and then a throwing task was performed immediately after activity, and points were rewarded every time the participant hit the appropriate target. Both fatigued and controlled participants performed the throwing task. Once the trials were completed, the pair swapped roles and started again to provide significant data in order to analyse the difference between being fatigued while trying to perform a certain task. Participants were a mixture of male and female volunteers. Once activity was performed, we calculated the results with the athletes, and then we calculated the averages to understand how fatigued has impaired an athlete and how did the control groups compare with the fatigued athletes. So as you can see, I don't have a very technical savvy brain, so I had to print this off and show you our results via a piece of paper on my iPhone. So obviously that's table 1 that has the fatigue scores of hitting the targets, then how many steps the fatigued athletes did over 10 trials, and how many the control group, which is known as the resting group, performed hitting the targets. This is the fatigued and controlled results in graph form, and then this is just the fatigue of steps each of them made and how they gradually increased and decreased. So the results below have been calculated to an average amount of points a fatigued participant and resting participant scored when throwing a ball in the 10 trials. Steps were also recorded for the fatigued athletes in order to see how fatigue has been placed upon the participants' muscles. From the results, we are able to see that as each trial progressed, the scores of the fatiguing participants started to decrease, indicating that fatigue has set in, which ultimately disrupts performance within an athlete. From the data, it is clear that both central and peripheral fatigue has set in, and the effects on the fatigued athlete appear to be both physically and mentally draining, thus affecting each trial. Once again, I'm real sorry about the data, but I couldn't really present it by camera, so I had to print it out and record it on my phone. So hopefully you guys could read and understand the averages that we calculated with the fatigued athletes and the controlled athletes. Anyway, on to the practical implications within the experiment. Within the experiment, the results had some implication towards the final results. As we can see, the results indicated that from trials 4, 5, and 6, and 7, all are decreasing due to peripheral fatigue. However, as these trials were nearly finished, the participant scores and steps increased from trials 8, 9, and 10. This may be due to the central nervous system as having the mindset to push through the pain barrier of lactic acid, as there are only very minimal trials left, and therefore this increased results may be caused from the central nervous system. Also, motivational support from lab partners may have influenced the increase of scores at the end, as encouragement usually tends to spur individuals on. As we look at the controlled group, scores tended to fluctuate. The control scores were very dominant up until trials 9 and 10, as they were almost beaten in the average throwing points. There are a number of reasons why this may be the case. Some participants found the activity to be very time-consuming, and by the end of it did not really care about the results. Thus, both controlled and fatigued participants may not have put 100% effort in, and assuming by that has resulted in a mixture of results. Another implication is a lot of participants involved in this experiment are quite active and usually play local sport or exercise on a regular basis. This may have impacted the results, as most athletes have been previously fatigued and thus activating peripheral fatigue a lot quicker than usual. This then affects performance levels, as athletes have already been affected by previous activity and unable to perform to the best of their abilities when conducting this lab experiment. Another implication, however, might be a minor thing to affect this experiment, was not many of the participants are really focused on reading the practical objective before arriving to the pract, and therefore assuming they weren't really prepared to take this prac on. So a lot of people were maybe lacking nutrition, or a lot of individuals may have performed physical activity the day before or even the morning before and had very sore muscles, so therefore could not perform the activity to the best of their abilities. However, athletes still did do the activity, and we had to use the results that were brought forward to us. Alright, so previous research has suggested that male and female athletes are different when it comes to fatiguing quicker. Billett and Bishop investigated the theory if female athletes were less prone to fatiguing quicker than males. The results ended up being quite similar, and the theory came back not true. Billett and Bishop suggested females may be less prone as they carry less body mass and tend to focus on keeping fitter than men, thus lasting longer in endurance-based exercises. The importance of this practical was to understand the difference between central and peripheral fatigue among individuals and how it affects their performance. Through this practical, we are able to understand that peripheral fatigue can affect performance. However, central fatigue is able to increase performance when in the right environment. A clear example of being in the right environment to experience both central fatigue and peripheral fatigue is playing a high level of sport. A high level of sport may be elite athletes who participate in NRL. NRL is a high demanding sport involving lots of muscular endurance and cardiovascular fitness. NRL players who have been selected to play a state of origin both for New South Wales or Queensland endure both pain physically and mentally, but however push through even though sustaining injury. A clear example is when, say, one of the participants in state of origin might have a broken jaw, but however, due to the game being a very important aspect and a high environment, the athlete then channels the central nervous system and uses the brain to activate the central fatigue aspect, whereas they can push through the pain and continue playing the game, and however feel the effects of pain later on once they have completed the activity. Once again, thank you guys for listening to my very quick video presentation of how fatigue plays on motor performance. I hope you guys have learnt a little bit about how fatigue can affect an individual's performance. Thank you for listening to my talk. Bye.